Our last example is the Fibonacci sequence. So we would like to find what is the closed form equation for the Fibonacci sequence. So like what we have done before, rewrite the recurrence relation as Fn minus Fn minus 1 minus Fn minus 2, which is equal to 0. Step number 2, you need to determine what is the degree of the recurrence relation. So degree is equal to 2. So step number 2, you find the characteristic. Polynomial or equation. And since this is degree 2, so the first term of the polynomial will be x squared minus x minus 1 is equal to 0. Now if I want to find the roots, again you can use the calculator, or you can use factorization, or you can use the general formula for quadratic equations. So you cannot factor them into two integers, so you can use the general equation for x, and the general equation for x is that x is equal to minus b minus plus the square root of b squared minus 4ac divided by 2a. So the value of a is 1, the value of b is minus 1, and the value of c is minus 1. So when you substitute, you will have x is equal to, now you will have 1 minus a plus b square, you will have 1 square minus 4 multiplied by 1. So b square is 1 minus 4 times 1 times minus 1. So the total will be equal to 5. So we have 5 and a is 1, so we will have 2. So therefore, we have two x's here. We have x1 is equal to 1 plus the square root of 5 over 2, and we have x2 is equal to 1 minus the square root of 5 over 2. And as you notice that the roots are not integers, they are irrational numbers. Now, step number 3, finding the general solution. So the general solution. The general solution for this recurrence relation, it is f of n is equal to constant multiplied by the first root over 2 plus the second constant multiplied by the second root over 2. And both should be raised to power n. So this is the general solution for the recurrence relation, Fibonacci sequence. Now finding the constants. Finding the constants C1 and C2. It is given that F0 is equal to 0. So n is 0. After you substitute, you will get C1 plus C2 is equal to 0. So that means that C2 is equal to minus C1. And for F1 is equal to 1. So we will have C1 multiplied by 1 plus the square root of 5 over 2 plus C2 multiplied by 1 minus the square root of 5 over 2. Both raised to power 1. Here is 1 and here is 1. Now since C2 is equal to minus 1, so we can substitute here. And don't forget that this is equal to 1. So by substituting, we have C1, 1 plus the square root of 5 over 2 minus C1, 1 minus the square root of 5 over 2 is equal to 1. So take C1 common. between the two, and since both are divided by 2, so we will have 1 plus the square root of 5 minus 1 plus the square root of 5 is equal to 1. I multiplied minus both for both 1 and minus the square root of 5. So it will be minus 1, and minus multiplied by minus is a plus. So minus 1 with minus 1 will go together. So we will have C1 2 square root of 5 over 2, because here we have square root of 5 plus square root of 5 is equal to 1. So 2 will go with 2. So the value of C1 will be 1 over the square root of 5. And C2 is equal to minus 1 over the square root of 5. So the Fibonacci sequence f of n is equal to C1, which is 1 over the square root of 5 multiplied by 1 plus the square root of 5 over 2 raised to power n, minus 1 over the square root of 5, 1 minus the square root of 5 over 2 raised to power n, and this is the general solution of the Fibonacci sequence. As you see that those roots are not integer. These roots are irrational, but this recurrence relation surprisingly gives us integers for any value of n. And if you remember that the Fibonacci sequence, it is every number is equal to the summation of the previous two numbers. So it is very surprising that when you plug a value for n, that this equation will give you integers.